Good morning, guys.
Yes, sir.
Okay, fine. No issues. Today we are going to discuss about some important topics or some introductory topics of robotics regarding robotics. I hope you didn't have this subject. I mean, you didn't have covered this subject so far. So I will be explaining you each and everything in this session regarding robotics and its process, what exactly robot means. Like, see, know the definition of robots, uses of robots, basics of robot movement, where and why we are going to use this one, advantage, applications of robots. All these things we are going to cover in today's session. I hope we know this one. This is called a cycle of technology, in which we are discussed about these missions and these process. In this process, there is one thing that is called as a R. R is nothing but robot. So why there is a need of R in the technology? What is the need of R in industry? Can anyone give me a brief on this one? What is the need of R or importance of R?
सर ऑटोमेशन को नेक्स्ट लेवल पे ले जाने के लिए
ऑटोमेशन को नेक्स्ट लेवल को ले जाने के लिए. Find any other things?
Repeatability, sir. Yes, yes, sir.
Repeatability. So whenever there is an automated application or some application which is continuously repeatable, at that application for increasing the efficiency, there is a need of or there is a scope of robotics over that application. So that what will be happen? That repetitive task will be done by a robot, with which I am going to increase my plant efficiency. This is the first main aspect of involving robots in an industry. Now, we have discussed this also industry 4.0. In this, one of the component is robotics. So we have to involve or we have to implement this robotics to the plant so that the plant is completely automated. Once everything was done, then we are going to digitalize it. That is also, so this is also one of the key aspect of the industry 4.0. Now we will be discussing about robotic terminology and robotics everything. These are the some of the definitions given by many organizations, in which first basic definition is robot is an electromechanical device. What is electromechanical device? What should be electromechanical device? Or give any example for this one if you know. Any idea?
Electric motors.
Oh,
Electric motors, like which uses electricity to do mechanical work.
okay. Mm, that is fine. One of the example electric motor, or else we call it a DC motor. In the DC motor, what will be happen? We are giving power to this row motor, and automatically this mechanical device will going to rotate. Then it should be like a electric motor, electric mechanical vehicle. Then what is electro? See, electromechanical is nothing but it is a combination of mechanical plus electrical plus electronics. Now, what is the role of this electronics in the motor? Same example, I am considering a motor application. In this motor application, this is a DC motor. In the DC motor, there is no any electronics involved in it. So we'll call it as electric mechanical device. Electric mechanical device. But what are those electromechanical devices? The definition means it is having mechanical components, it is having electrical components, it is having electronic components also involved. Any example for these three? So if there is a component, that component is having all the three, then what should be that component? Any example?
So if we use sensors to switch on or switch off, then it can use. If we use sensors to switch on and switch off the electric motor, so
Okay,
can it be combined called electromechanical?
okay, fine. We are doing some additional work to this motor. I mean, there is a switch that should be regulated, which means it's an external device. I don't want any external devices. I want this motor to be involve all these components. So is there any motor like this which is having mechanical components, which is having electrical components, which is having electronics component also? Is there any motor like that?
Such stepper motor
Yes. Servo motors, stepper
controls.
motors, all these are called as electromechanical device. When then where what will be happen? The same mechanical device, the device is not changing. The same shaft, the same outer casing, everything is same. Here the power supply is also same. There is a power positive and there is a negative supply, so that to run the motor. But if at all I want to monitor the speed, if at all I want to regulate it, if at all I want to collect the feedback, then there is a need of some servers or some PLCs involved in it. That is called as electronic devices. So together is called as electromechanical device, which means a device, a mechanical device which is having a combination of electrical as well as electrical combinations. That is called as a electromechanical device. Best example is servo motors, stepped motors, all these called as a electromechanical devices. Okay, here this robot is also one of the thing called as a electromechanical device. Why? Because the robot itself is having a mechanical device. If at all I am talking about this thing, this is a robot. Okay, if at all I want to move the robot, this is a mechanical device, so mechanical was enabled, mechanical was done. Now I want to give the power supply. Power supply is nothing but electrical power supply. Then what is the need of electronics in this robot? What is the need of electronics in this robot?
Some
To
movement.
give instruction.
To give instructions. Okay, someone is saying movement. What is movement?
Movement of the arm, sir, to get the precise location.
Okay, to get the precise thing. Or if at all there is a movement, there is a movement done from this to the movement, the robot will be moved to this location. Now how much it will be, how much it was rotated. So if at all I want to calculate it, if there is no any electronic device involved in it, then what will be happen? It is difficult for me to calculate this angle directly in a robot. So to get all those things, to get the sensors, how much displacement it was having, how much distance it has covered, so how much load it is picking, so what is all the climatic conditions, what is the robot itself conditions, to get all the things, there will be having some sensors involved in the robot. So now what will be happen? These sensors will track the movement of the robot and it will give the feedback to this robot controller or robot. So there is electronics part is also needed for the robot. That is why robot is a electromechanical device, which means the mechanical component which drive with the help of electrical thing, and it can be controlled by some sort of sensors. That is called as a electromechanical device. Simply the robot definition is it's a electromechanical device. Okay, with multiple degrees of freedom. Now second again another question. What is degrees of freedom? Any idea on this one?
सर वो
Number of
कितने डायरेक्शन में
directions
मूव
in
कर सकते?
which
Okay, kitna
free
direction?
movement is allowed.
Sorry.
Number of directions in which free movement of the body is allowed.
Okay, fine, that's correct. Simple definition I'll explain you. If it is a chart, if there is an x-axis and y-axis, if there is a point is there, there is a point here. Okay, now the point is not having any dimensions involved in it, which means it's a fixed one or it can be movable. There is an axis here, x and y plane. In that plane there is a point a. This point don't have any dimensions involved in it, so this point is fixed or it will be movable one.
Some movable in
Why?
two
Because
directions.
we haven't given any dimensions, so that what will be happen, the movement of the particle is not fixed. So that what will be happen, this point should be here or it should be here or it should be here, it should be anywhere in this plane, in this region. If at all I'm call this as a region or a plane, in this region this point should be anywhere. Okay, this is called as a movement of the part, degrees of freedom. That is nothing but movement of a particle in this plane. Okay, if at all I'm talking about a line, there is a line and a point is there, same B point. Now I haven't given any dimensions. Now what will be happen? In which direction it should move? This is x-axis. In which direction it should move? This is a plane, okay, and this is a line. In this line, in this plane, this particle is going to move in either in x direction or in y direction. So it should be having, let us take 2 degrees of freedom, 2 DOF. Now I am considering an example of line, and there is a point here. Now in which direction this point should move? How many directions it
Along
should move?
x-axis.
Okay, along x-axis. So why can't it move on this direction? Why it is not going to move?
Sir, with the restricted this movement.
Yes, we have restricted movement, and we said that there is a line. In that line, there is a point. So, which means line is nothing but it is only in one axis. It shouldn't be in two axes. So, there should be one constraint I have given. So, the point will supposed to move in either plus or minus x direction. So, this line should be having 1 degrees of freedom. So, it will be moving in this direction or this direction. Now, what will be happen if it is in a space? Now, can you tell me how many degrees of freedom it should have? If a component is there here, in how many directions it should supposed to move? Component C.
6, sir.
Okay, 6. Okay, we will talk this 6 later. First I will say in 3.
3, sir.
Why? Because positive and negative x-axis, positive and negative y-axis, positive and negative z-axis. So I will say 3 linear motions. Okay, the degrees of freedom of the point is 3 linear movements. In linear direction there will be having 3 degrees of freedom. That is called as degrees of freedom. Degrees of freedom is nothing but movement of a component in space or in a plane or in a line or in a given region is called as degrees of freedom. Clear? If there is a chamber is there, cylindrical chamber is there like this. In this cylindrical chamber there is a component. Okay, if at all I have rotated this one, this cylindrical chamber continuously, then in how many directions this component should move? If at all I'm talking about linear, then it should supposed to move in this direction, in this direction, in this direction, x y z in linear directions. It should be having 3 degrees of freedom. Clear? A movement of a component in space is called as a degrees of freedom. Okay, but it is not restricted to linear. There will be having some rotary also, that we will be discussing in the later phase. First we will be discussing only linear direction only. So in linear direction there will be having x, positive and negative x, okay, and positive and negative y, and there will be having positive and negative z. So it should be having 3 degrees of freedom in linear directions. Any component should be having 3 degrees of freedom in linear directions. Okay, together the component will be having a maximum of 6 degrees of freedom, which means every component there will be having rotation also. If there is a rotation along with x-axis, if there is a rotation along with y-axis, if there is a rotation along with z-axis, so then there will be 6 degrees of freedom. Any component, the maximum number of degrees of freedom is 6, so that the component can move in a space. It should be moving in 3 linear directions, that is x, y and z. It should be supposed to rotate at an angle on x, y and z. So together every component or maximum all the components should be having 6 degrees of freedom. It is a freely movable in space. Okay, that is called as a degrees of freedom. Now we will be considering the complete definition. A robot is an electromechanical device with multiple degrees of freedom, which means a mechanical component which should be controlled by a sensors as well as electronic as well as electrical part, and it should supposed to move anywhere in the given region is called as a robot. Okay, second one is this is a programmable to accomplish various tasks. Anyhow, this if it is a there is electronic media is there or a controller is there, by using that controller we can create any type of component, any type of program by using this one. That is called as a robot. A robot is a electromechanical device with multiple degrees of freedom, which means a mechanical device which is capable of moving anywhere in this given region is known as a robot. Why there is any creation of robot is there? So to accomplish any program, that is one of the task. So a robot is an electromechanical device. This is a structure and it's supposed to move in these directions. For what purpose we are creating it? For creating n number of programs, any type of program that can be created with this thing, that is called as a robot. Clear? This is a simple textbook definition which was given by some AICTE. And When coming to other one, then there will be one more definition, industrial robot. If at all we are talking about industrial robot, then the robot or industrial organization RIA has defined the robot in the following way. An industrial robot is a programmable, multifunctional manipulator designed to move materials, parts, tools, and special devices through variable programmed motions and performance of a variety of tasks. See, both are all similar. Here, they have defined each and every in separate manner. See, an industrial robot is a programmable. Here, see, same thing. This robot cannot be, I mean, if there is a robot is there, that robot is not constrained for a single operation. If there is a pick and place application is there, material handling, the robot need to pick material from this and it need to place this here. So this robot is not at all constrained for this single application. The robot is having a combination. The robot is having the capacity of doing n number of operation, any operation that can be performed by using a single robot. That is what exactly it is describing here. An industrial robot is a programmable, any type of program we can perform it. Multifunctional manipulator. Okay, manipulator is nothing but arm. Robot, the robot is having 5 different manipulators, which means 5 different arms like this. In this application, the robot is having one, two, three manipulators or 3 arms. We'll call it as a 3 arms. Okay, multifunctional manipulator, which means it can be capable of doing any function. Designed to move, see, there is an application here, designed to move materials, parts, tools, and special devices through. So these are all the different applications which can be performed by using this robot by using a program. That is what exactly industrial robot definition is. Industrial robot definition is nothing but it's an industrial robot is a very which is capable of doing any type of program by using multifunctional manipulators to design or to design to move any type of component. That is the simple definition for the by this RIA. And there is one more definition that is given by ISO, that is nothing but standard organization, international standard of organization, which defines a robot is an automatically controlled, reprogrammable, multi-purpose manipulative machine with several reprogrammable axes, which is either fixed in a place, which is used for the industrial automation application. See, this is also similar. A robot is an automatically controlled. Why exactly it is automatically controlled? So there is a need of some sensors. There is involvement of some sensors as well as controllers in the robot, with which what will be happened if at all I have given some command. Here there is a wall is there. If at all I want to give a command with which the robot need to move to this direction, but the robot won't move. Once it was reached this location, the robot automatically stops. Why? Because there are some sensors that will be built on this robot which will predict the motion or which will predict this collision, so it will automatically stops. This is called as automatically controlled. Whenever there is an occurrence, whenever there is a some control is needed from itself, then this called the robot is automatically controlled, reprogrammable, any type of program that can be created as well as modified. If at all I don't want it, I can delete it. That is reprogrammable. Multi-purpose, we can do any type of operation, any type of application, that is called as a multi-purpose. Manipulative device, nothing, manipulator is nothing but arm, so manipulative machine with several reprogrammable axes. So out of these definitions, this is the best and apt definition, which is nothing but robot is a electromechanical device with multiple degrees of freedom that is programmable to accomplish any type of task. Just a second. Okay, this is called as a simple robotic definition. Now, this is the robot definition that is given by Siemens. And a robot is an electromechanical device with links and joints, guided by sensors, driven by actuators, and controlled through a programmed software to handle and manipulate parts, materials, tools, and devices for programming various tasks in variety of environment. According to the Siemens, it is given definition as a robot is an electromechanical device, which we have discussed, with links and joints. Like already told you, see, this is a arm. We call this as a arm. There are 3 things. Either we can call it as a arm or link or manipulator. Anything is correct in this terminology. We can someone call as a arms, some will call as a links, some will call as a manipulators. So all these things are same. A electromechanical device with links, which means n number of arms. If some robots will be having 5 different arms, some robots will be having only 3 arms, some robots will be having only 2 manipulators, some robot will be having only 1 link. All these nothing but the links, the arms of a robot. And joint is nothing but the connecting part between these two, see here, this arm and this arm is connected by a link or by a support, that is known as a joint. Okay, if there is a arm is there and there is one more arm is there, so this connecting point is called as a joint. So there will be having a number of joints. If the movement is constrained to rotational, then there will be need of some special joint. If the movement is a linear like this, then there will be need of some other joint. So based upon the movement, this joint will be defined. So a robot is an electromechanical device with multiple arms and joints. If the number of arms is increasing, automatically the joint number is also increased. At the same time, if the link is a linear link, then automatically this joint will be deferred. If the link is a rotary link, then automatically this will be deferred. Based upon the link, it will be changing. Next one is guided by sensors, which means nothing but if the row I have given some program like x50, okay, x50, so that this main axis, this axis is going to rotate in 50 direction, 50 degrees, but positive 50, I have given positive 50. But in positive direction there is a valve here, so that only 20 degrees only it will rotate. Other than that, what will be happen? It will collide with that wall. So at that point, there will be having some sensor. There will be collecting the feedback and giving to the controller. That is guided by sensors. And I have given 50. So if I have given negative 50, then what will be happening? It will control to the negative 50 and it will stop. So how can I supposed to estimate this one? Whether it will be moving to negative 50 or minus 49 degrees or 51 degrees? How can I supposed to calculate it? By using sensors only. That is nothing but guided by sensors and driven by actuators. Actuator is nothing but, see, this is one of the technical term in this robot. Actuator is nothing but the power giving mechanism. So I mean, how exactly the robot is getting power, whether it is the power is getting by motors or hydraulic or pneumatic, these are called as actuators. So how the robot arm is moving, on what basis, on what will be the input, so that will be defined by this actuator. Okay, so if it is a motor, I am using some servo motor or stepper motor for this application, then it will be driven by electrical. If at all I am using some hydraulic application for lifting some 50 kg or 60 kg load, then the actuator will be driven by hydraulics. Then there is a pneumatic application, small application, which will be weighing less than 2 kg or 1 kg. Then at that application, I will be using this actuator, pneumatic actuators, which means air controlled actuators. Driven by actuators, nothing but this is the medium where my input will be given, okay, to this one, and it will be giving command to this robot. This is called as the actuators and controlled through program software. They should be having some software to control the complete robot. So according to Siemens, this is what exactly their definition is. A robot is an electromechanical device with links and joints guided by sensors and driven by actuators and controlled through a programmed software. That is a simple definition of a robot. For what purpose we are doing? To handle and manipulate. But these are the applications to handle, manipulate parts, tools, devices for programming variety tasks in this robot. So that is a definition given by Siemens. Okay. Now we will be entering into one of the important topic. So we have discussed what exactly robot is till now. But here one more thing. Why? How exactly this will be coming into existence? So what is the need of robots? Where exactly it was derived? So how this terminology comes into existence? All those things we will be discussing in this slide. First one, concept of robot. The study and understanding robotics is an interdisciplinary domain consisting mainly of mechanical supported by electrical, electronics, and computer streams. If at all you want to be mastered, if at all you want to achieve some special skills or technical, if at all you want to be expertise in robotics, then you should be having these skills, all these skills, not only mechanical. Definitely there is a need of mechanical. Why? Because if at all you want to move the robot, then you have to calculate the kinematics as well as dynamics of the robot. That thing should be learned in the mechanical stream. But at the same time, apart from the mechanical, you have to be thorough with electrical, electronics, and computer streams. Why? Because how the power is coming, how much power it is taking. So you the robot is lifting some 50 kg. At that condition, what will be the maximum power load? So all the for all the things you need to learn this electrical concept also. At the same time, electronics. Why electronics is, if there is a sensor is there, so I want to give some command for that. So how exactly I will be giving? Or if there is a sensor, if at all I want to involve some vision inspections or some special applications for the robot, then there will be need of some PLCs or some sensors. If there is a need of sensor, then automatically there will be need of PLC also. If there is a need of PLC, then definitely you should be having some electronics idea or coding idea. Then you need, at that application you have to be thorough with this electronics also. Then automatically this complete program, if at all you want to operate this complete robot virtually, I mean there should be having some controller in our hand. So by using the controller we can define the program, which means if the robot application, there is a pick and place application, the robot pick a material from this and it will be reaching to this direction and it need to place here. This is a repetitive task. I want to run this application for 1000 number of terms. So how I need to write this? Do I need to write 1000 lines of program for each and every application? No. At this point, I have to give some loop condition, or if at all I need to give some while condition. So that what will be happen? I have given the first condition like this. The robot need to pick. So once the pick is done, then it need to place. Then I will be creating a loop here. Loop n equal to, I will be giving n less than or equal to 1000. Run this line 1. Else, if condition, I will be using if and then else exit. So how exactly I have defined this one? By using some computer language only, by using some Java as well as Python language only, we will be creating complex program. If a robot is there, if a robot is there and that robot need to be programmed like this, the material need to pick from three different locations. There is a robot here, the robot need to pick material from these three locations and it need to deliver to two different lines. This will be one line, this will be one line. Okay, now the robot need to define, the robot for every first minute the robot need to reach over there. After this part was done, then automatically it will be reaching this position. Once it was done, again it will be reaching to this position. So after 4 cycles, then the robot need to pick a part from this one, and this part from the second mission, 1 2 3. From the second mission, the material need to distribute one from here and one from here. Whereas all the first parts will be delivered to this one, 1 1 1 1, and there is a need of 2. Same here, 3 3 3, and there is a need of 2. Like this, it need to deliver. Now, if this is a complex application, if there is a complex application, then how can I supposed to do that? Without software, without this computer knowledge, without the Java as well as Python, I can't create this type of things. So then if at all you want to learn, I mean you want to achieve more skills in the robotics, or if at all you want to create a number of applications, then there is a need of programming also. That is what exactly this is describing. So if at all you want to achieve some special skills, or if at all you want to learn robotics completely, then you should be having clear idea on the mechanical concepts. At the same time, there will be having some basics that will be needed from the electrical as well as electronical as well as computer science. With a combination of all these things, then only you will be achieving masters or achieving higher knowledge in this robotic terminology. Okay, next one. Various links and joints are to be designed for strength and rigidity through static as well as dynamic force analysis. I have already explained you what are links and what are joints. Links are nothing but robotic arms. If at all the number of arms will be increasing, see here. Now what will be happening here? See, 1, 2, 3, 4, 5, 6. This robot is having 6 different arms. Now here there is a end effector is there, nothing but there is a gripper is there. With the gripper, I need to pick a part and need to read this location and need to deliver it. Now what will be happen to this robot if there is having this one? If the number of arms or joints are increasing, then what will be happen? I need to search, I need to design the robot, I need to search the application. So if at all I want to move too far to this location, then what will be happen? I need to check how much strength the robot is having. So the base need to be fixed in the ground. So how the base was mounted, so whether if at all I reach the maximum condition, whether the robot will withstand the application, whether it will be having the strength to hold the component or not. So how much precisely it will be giving the components. If the robot is reaching to this location, it is completely far away from this one, which is like a cantilever beam. What will be happening? If the cantilever beam, always the beam will deflect to downward direction. Why? Because there will be having a cantilever structure. So there will be having one from this one and the beam is like this. Now what will happen? There is a load here, It's self load that will be happen. At the same time, the robot is picking some material. What will be happen? This will be more at this condition. What will be the robot behavior? How exactly it will be moving in static, which means a rigid conditions. Dynamic is nothing but lifting a component, it will be moving to this location. Now what will be happen? So all these things we can analyze by using this robot before entering into robotics. I mean, if at all I want to create this type of application, so I should be theoretically correct, I should be theoretically given some conditions or given collect some values, so that what will be happen, the robot will go to this condition. At this condition, these are the factors that will be affecting robot. I am getting some 20 kilopascals load at this condition, so that 20 kilopascals load can be manageable by the robot. If it is 20, more than 20, if it is a 120, then what will be happen to the robot? The robot can't do that application at that conditions. In a dynamic condition, this part can be done in the analysis part before doing this robotic thing. That is what one of the main thing. So if at all I'm increasing a number of arms, or if at all I'm increasing the number of joints, so that I need to consider these things also. What type of application I'm performing here. So if the application is more, if the application is weighing more, which means if it is a 50 kg or 60 kg load that I need to pick, then at that application how exactly this will be defined. Here I'm using a small robot which should be having height of 5 feet. Now in the height of 5 feet, if at all I'm using some 6 different arms, now what will be happen at the sixth arm? So what will be the analysis? What is the strength? So how, what, where exactly the robot is going to fail? I need to calculate all those things. That is this point. Next one is electrical and hydraulic pneumatic actuator produce various robotic motions. These are nothing but how exactly the robot is moving. So based upon the movement of the robot, how it was defined. So if the application is a limited one, if the application is just need to pick some 2 kg of load or a 1 kg of load, 1 kg of load I need to pick, then at that application they should be having a pneumatics that is needed. So now the pneumatics nothing but air. By using air medium, the robot will close the gripper by using this one, and it will pick the part and it will place. So what will be happen if I use a pneumatic to pick 50 kgs or 60 kg of load? Hmm? What will be happen if I use pneumatics for lifting a chassis or for lifting a car body, so that it need to go for a spot welding application? Will it be performable?
No, sir.
Have you seen this pneumatic applications anywhere?
No, sir.
Have you seen these pneumatic applications? Guys,
So not sure.
okay, not sure.
So वैक्यूम की हेल्प से लिफ्ट
Yes,
करते हैं.
yes, there is a compressor here. Okay, how exactly it was working is, there is a air compressor is there that will drive the pressure, that will increase the pressure in the air, and it will be delivered through a chamber, and it will be connected to the gripper. There is a gripper like this, and here there is a gripper. Okay, this vacuum will be given to this gripper, so the gripper will be moving in this direction. So whenever there is a component that comes into here, so automatically this will suck the air from this one. So automatically what will be happen, both will comes to this location, and it will hold the component by using this pressurized air.
So your pointer is not moving on the screen.
Okay, there is no any point. So sorry, I have seen now. Okay, fine. See here, there is a air compressor is there. I hope you know air compressor. This will compress the air and it will given to the gripper. There is a gripper. Just a second. Okay. There is a movable gripper here, and this pneumatic connection is given to this one. Now what will be happen, because of the pneumatics, the gripper side mounts will move in this direction as well as in this direction. Okay. Now what will be happen, whenever a component is there, so automatically it will reabsorb the pressure. Then what will be happen, it will be entering into here, and it should be vice versa. If they will be giving pressure, so that what will be happen, there is a chamber here, so because of which the two jars will be coming to the center direction, and there is a part that will be holded. Now This will hold this gripper. Okay, now if the component weight is less than, I mean 2 kg or 1 kg, so automatically that pressurized air can hold that. Okay, if it is a 50 kg, then what will be happen? This pressurized air is not able to lift that component. In that application, the pneumatic applications will going to fail. That is why pneumatics is one of the application where which is used for the lighter applications. The application which is a precise, the application which is a lighter in weight, and it need a precise, then we will be using this type of things. Okay, whereas hydraulic, if the application is 50 kg, then automatically the pressurized air oil will be injected into the same gripper, and it will going to hold this component. Like based upon the application, we are going to use electrical, hydraulic and pneumatic actuators for giving the robotic motions. That is the third thing. Next one is required positions are computed through transformations. Okay, what are transformations? Any idea? I hope you are done with kinematic subject, right?
Yes, sir.
In that, there will be having a forward kinematics, there will be having inward kinematics, right? What are those? Or why there is a need of kinematics? Why there is a need of forward as well as negative, I mean inverse kinematics? Okay, fine, no problem. I will explain you these thing when the kinematics, okay, chapter comes. There is a this thing also involved in the presentation. So when the kinematics come, I will explain you what are these transformations, how the forward will be moving, how the inverse will be moving. So what is the need of forward as well as inward in this robotic terminology? I'll explain you when this chapter comes. If I'll explain you now, there will be having a bit confusion. That is why I am not going to explain now. So maybe in the tomorrow session or day after tomorrow session, I will be explaining you this kinematics. In that, I will be explaining you these things. Okay. Next one is the electronics contribute in the type of control system closely achieve the desired output with the achieved output. What is this thing? So we are using some sort of sensors to control the robot, to get the feedback from the control. To get all those things, we will be using some sort of sensors. Because of the sensors, we will be collecting each and every data at every location. So if the location is somewhat 0 degree, then we will be collecting the data. So if the location is having some 30 degrees, so we can be calculating the 30 degrees. If there is a need of 40 degrees and 5 minutes, that can also be possible by using the complex robots, and that data can also be tracked by using this electronics chapter, these electronic components in the robot. The next one is the computer program add flexibility in performing various variety of jobs executing the robotic manipulators. See one thing, like already explained you, if the program is complex, if at all I am going to do any type of complex application, like picking a part from this one and giving it to some other, and again going back to some other station, and it need to wait for the component to come. Once the component will be reached to that location, then based upon the sensor or based upon the vision sensor, so it will need to collect the part, and based upon the dimensions it will be giving to some other conveyor. If the application is having this much of complexity, and we can't produce that type of applications manually, so if there is an application is there, then definitely there is a need of computer programming for creating flexibility, for creating easiness in the program generation. That is what exactly the main necessity of a computer program in this robotic terminology. So whenever there is a need of complex programming, or whenever there is a repetitive task, whenever there is a conditions, which means if this robot need to run for 10 repetitions here, once the robot 10 runs was done, then it need to reach to some other location to do some other application. At that application, what will be needed? It is a program, it is a condition we have given to the robot. So to give the condition to the robot, definitely there should be having some language with which the robot will understand. That language is nothing but a computer programming, which will be controlled by Java as well as Python. So by using these three, so you can directly give some easy programs to this robot so that the robot will perform the applications. That is one of the thing. Next one is the software programs with the deployed developed algorithms, controllers, sensing make the robot to process intelligence to carry out the jobs in the work environment. That is known as degrees of freedom with the links. By using all these things, the robot itself is having a controller. That controller is having capable of controlling all these things. There will be having a joint jogging, which means joint moving. There will be having the link moving. There will be having some programming if at all you want to do. There will be having some programming if at all you want to reset the sensors or reset the tools, everything. Then there will be having that also if at all you want to do some WCS home, all those things. So you will be having every algorithm or every thing that will be involved in the controller so that the robot will be controlled. Or if it is a newer run, you can directly install it. If it is a existing one, if at all you want to reset it, you can control that in this by using the set of algorithms. So this robot, the concept of robot is nothing but how the robot is performing, what are the different things that will be involved to run a robot. So what are the things we need to consider before starting a robot? Those are the things we have discussed in this one. Okay, so we have discussed what and why. Now, what are the benefits of robots? Benefits of robot nothing but reduction in routine operations, creation of more interesting tasks, increase in production capacity, greater flexibility, higher precision and accuracy. These are the some of the benefits by using robotic terminology. And these are the some of the reasons why we need to adopt robotic technology to our plant. Increase in productivity. If there is a repetitive task is there, if there is a material handling, continuous material handling is there, if there is an inspection is there, if there is a manual operating is there, where the application is continuous and the production is not at all monitored, not at all increased, at that applications you need to go for the robotic technology where you will going to increase in the productivity. Second one is due to high cost of workers as well as shortages. Some of you has already raised in the previous sessions. So what will happen if there is a strike that was created by the human, if there is a delay, if there is a rain or something, if there is an operation, if the human is not attending the particular operation, if the labor or the workers are not entering into the plant because of some things, at that thing what will be happen, if what do I need to shut down my plant. So at that applications, if there is a automated vehicles, automated robots that will do these applications, then it will be cost saving to the industry. That is one of the thing. Second one is high cost of raw material. Nowadays what will be happening, raw material cost is completely increasing. So if the raw material cost is increasing continuously, now what will be happen, the material which we are going to produce will also be costlier. If something may happen because of the material handling or because of the human effort, something may happen to that product, then what will be happen, this will be rejected. Now I don't want this rejection rate. Why? Because the input, the production rate is increasing. So if at all I want to sustain in the market, if at all I want to maintain these things, then automatically there is a node of robot where it will be controlling each and every part in a precise manner. If I am giving some things to the robot to pick the part from this location, and by using CNC machine it need to control all these things, then this will also be possible by using these things. After that there will be having some safety. If at all we will be using some hazardous application is there, generally this robot will be used in 3H applications. We will call as a 3H applications. 3H, high risk, hazardous, and there will be some more H. I don't know exactly, I forgot it. There is a 3H applications where we are going to use this robots, which means if it is an hazardous application, which means if there is a spray painting application is there, if the spray painting application need to do manually, then what will be happen, the sprayed paint will be coming through with a pressure. That pressure, what will be happen, if he inhales, if a human is there in this application, if he inhales is accidentally, even though he wears the mask and everything, but some particles will be entering into the human, so which will create some hazardous things to the human. That is one of the application. And so some will be just a second, dull, dirty, danger. Yes, it's not a 3H application, it's a 3D application. We'll call it as a dull, dirty, and danger. Yes, this is not H, this is 3D application, which means dull. which means if there is a low light is there, if the robot is going to perform some applications where it is underneath some sixth floor or seventh floor, where there will be having a limited light, where there will be having some limited scope, at that application what will be happen, if a human it works continuously, then it will be some problems to the human. At that applications we can use the robots, that is a dull applications. Dirty application nothing but if the environment is completely skiddy, if at all I am using some application where the material cutting is happening and that chips will be all over there, at the same time there is an oil application is there, and while for operating that operation what will be happen, the oil will be spilled everywhere even though it was covered. Now this is a skiddy environment, this is a dirty environment, at that application also we are going to use this robot which will be withstanding even though it's a dirty application. And third one is a danger, that is nothing but hazardous. If if the CNC machine or if the robot is operating some part which is more than 150 degrees temperature, 100 degrees temperature, what will be happen if a human is there, it will be having some defects if the human is there. Then at that application also we can use some sort of robots to sustain these conditions also, that is called as a 3D application, dull, dirty and danger applications, that is safety. Next, improved product quality. Of course, if at all we are using a robot, so that what will be happen, my raw material will be precisely operated or monitored, so that I will be getting quality at the end of thing. Reduced material lead time. Lead time is nothing but the material is coming to this process and it will be going and it will be reaching to the final one. This is called a cycle time or a lead time. So how the material is moving, so how can I improve this one, if at all I'm using a robot for this material handling. So which means a robot is here, a robot is picking a part from the conveyor and it will be delivering to the direct workstation. So that what will be happen, the robot will do its application, once it was done then it will be again, and the robot is there, it will be collecting material from that mission itself and it will be giving to some other mission. So because of that what will be happen, my lead time will be reduced, cycle time will be reduced for that part. So these are the some of the reasons where we are going to use the robotic terminology for increasing the efficiency. Okay. And next one is strategies. So if at all I want to use a robotic terminology, then these are the some of the strategies that I need to adopt. That is nothing but specialization in the operations, combined operations, simultaneous operations, integration of operations, increased flexibility, improved material handling, online inspection, process, and sim. These are the some of the strategies where we are going to use this robotic terminology for increase in our plant efficiency, which means specialization of operations. If the application is completely, see, these four are almost similar, but end application will be differed. If there will be having five number of operations, each and every operation will be performed by a human. Now instead of this one I will be removing all these things, I will be creating a rail over there, I mean a track over there, and I will be using a robot. So the robot will pick the part and it will be doing some application. Once it was done, it will be reaching to this location, it will be doing the same application, same it will be moving to this one. This is called as a combined operation or integration of operations, simultaneous operations, specialization of operations, all this comes under this type of application. So where what will be happening, operations will be combined simultaneously, at the same time it will be integrated, so that what will be happening, my rate of production will be increased because of this one. Increased flexibility. So if at all I'm using a robot, so instead of directly fixing it to a CNC machine, there is a CNC machine is there, so what I need to do is I need to fix this part over this location and I need to do some application over here. So once it was done, then it will be entering into the conveyor. Now I will try to improvise this one. The improvisation is like the robot is picking directly part with in this one, which means the robot will be holding the component from base and it will be holding like this. So the tool will come here and it will do its operation, and once it was done, so automatically the part will be traveling to the second mission. This is called as some of the improvised material handling or flexibility. So this is how I can increase the productivity or increase the quality of the product or increase the flexibility of the missions. This is one of the. Next, material handling. Anyhow I will be using this type of robot, so that what will be happen, material traveling time, material handling between stations can also be reduced if at all I am going to use this type of robotic terminology. Process control. So if at all I want to develop this type of operation, definitely there should be I should be having the complete knowledge on this one. So how I need to control the process, so how exactly I need to control this one, so how much time it should be here, how much time it should be here, so what will be the material processing time, so how the material handling will be there, so how the robot is picking the part, how exactly it will be giving to the station once it was done, how the robot is picking the part, because of picking the part will there be any surface damage will be there or not to that part. If at all I'm using some mechanical gripper, what will be happen to the component which at all I'm preparing. So in this application, what will be happen if I use a rubber gripper? If the material is having some high temperature, what will be happen if I use a rubber grippers? Like I need to have some complete idea on the process, so that what will be happen by using these robots, by using this one, so I will be controlling the complete process. So if the material is having heat increased, if the material is increasing the temperature, I mean, from here there will be having 30 degrees, here it will be 40, 50, 60, finally it will be reaching to 70 degrees. So now I know the process. So at this application, I can't use a rubber gripper at this application. I can use the mechanical grippers or a metal gripper, so that what will be happen? It will withstand the component, it will withstand the heat. At the same time, I need to consider this also. So if at all I use a mechanical grippers, what will be happen to this one? The component is completely smooth in nature. Why? Because it is hot in condition. So even the small pressure, excess pressure, what will be happen? It will give an dent to a component. It will give an impression to the component or the workpiece which you are going to produce. What I need to do at these applications? All this called as a process control. Now SIM is nothing but, I have already explained you SIM, CAD, CAN and SIM, which is nothing but computer integrated manufacturing. So if at all I want to improvise the production, completely plant production, then I need to involve some of the robotic technology wherever it is needed, so that the plant optimization can be done. At the same time, the efficiency can also be increased. These are the some of the strategies for using this one. Okay, I will show you this video at the end of the session. Now. Till now we have discussed about robot history. Now we are entering into robotic era. So what exactly a robot? How it was classified? What are its skeleton? How it was defined? What are its components? So based upon the components, how robots will going to differentiate? How the robots will going to move? All the things we will be discussing in this phase. First, I will be explaining you all these things. Once it was done, then I will be entering into this. Like already explained you, manipulators are nothing but arms. See, this is upper arm, lower arm, this is all known as arms. Okay, or I'll say link also. See, link, arm, both are same. Link, arm, manipulators, everything is nothing but a robotic arm, robotic, not joint, robotic structure, where it will be connected to the other structure, that is called as a manipulator. A manipulator is nothing but an arm of a robot. That is the simple definition. So this robot is having two different arms. So the robot is having two manipulators, two links, or two arms. That is what a link or a manipulator or arm is. Next one is a drive system. Drive system is nothing but actuators. I hope I have explained you this also. Actuator is nothing but, see here, there is a motor is there, which means it is a electrical operated. It is a electrical driven. That is a drive system, which means the robot is going to drive by using a component that is called as a drive system. This drive system can also be called as a actuators. And there are three type of actuators that are currently in use. That is nothing but electrical, that is nothing but a motor, and second one is a pneumatics, and third one is hydraulics. Based upon the application, these three actuators will be depend upon, these drive systems will be depend upon. Next one is control system. Control system is nothing but, each and every robot should be having some sensors that will be involved in the control robot controller. So how we are going to control it, on what basis we are going to control it, how the sensors will be placed, all the sensor related activity can be driven by these control systems. Next one is end effector. End effector is nothing but this one. End effector or wrist, both are same. Okay, which means if at all I'm talking about my hand, so if we're talking about a hand, what will be happen? Our wrist is nothing but end effector. With the wrist, what we are going to do, we are going to pick a component, we are going to do a painting, we are going to sign it, we are going to do some sort of application. So all these applications can be done by wrist itself. So end effector is nothing but wrist. Okay, end effector is nothing but the component which is going to mount at the end of a manipulator, or at the end of a link, or at the end of an arm, is nothing but a end effector. Okay, next one is sensors. Central sensors as well as control systems are both are same. So the control system will be having sensors that will be inbuilt in the robot. Vision system is nothing but, some robots will be having some vision applications. At that applications, we are going to use this vision thing. Last one, computer software and hardware. If there is a controller, if the robot need to be operated, then there should be having a controller, just like our joystick, where we will be having n number of buttons here, movements like this, and there will be having some software. It will be like a tab. So it will be like a tab. So in the tab everything is involved in it. There will be having some emergency button, there will be having some buttons for which my robotic manipulate, I mean the arms need to be moved, the joints need to be moved. If at all I want to do some programming, that program can also be performed in this one. It's like a mobile phone. So everything can be operated, everything can be controlled by using this controller. In this controller is having computer software involved in it and the hardware connections that will be completely controlling this robot. So these are the some of the components of robot. Now coming into this one.
सर
Yes.
सर एक बार ये एंड फैक्टर्स के बारे में दोबारा बताना सर.
Yeah, I will explain you. See, now we will be discussing this one. Here I am going to explain all these things again. Like here, manipulators, see, link, lower arm, upper arm, all are same. Everything is a manipulator, which means this joint is a, this arm is nothing but a manipulator or a arm or a link. So if the robot is having like this, okay, now see 1, 2, 3 and 4. Now this robot is having 4 manipulators or 4 arms or 4 links. So that is what exactly a manipulator is. Arm of a robot, joint, not joint, arm of a robot or a link of a robot is called as a manipulator. Okay, now the connecting part between these two is called as a joint. See here, there is a circle involved in here. This is called as a joint. Okay, if here in this application there is a J1, this is J2 and this is J3. This robot is having 3 joints and 4 arms, arm 1, arm 2, arm 3 as well as arm 4. 4 arms and 3 joints. This is nothing but driven motor, okay, drive control or actuators. Every robot can be either, it should be having 3, so either a motor or a pneumatic assembly or an hydraulic assembly to give power, to give input to the robot to do the operations. That is called as actuators or drive system. So here in this diagram there is a need of motor, so there is using a motor. So we will call this motor as a drive system or a actuator. Okay, if there is application is more, if this application is going to lift some 100 kg component, then there will be a cylinder between these two arms, piston and cylinder assembly is there between these two components. So that what will be happen, this will give power to lift the component, lift this arm to some direction. Then this is how the component will be, that is actuators or drive systems. Power cable is nothing but how exactly it will be doing, how the deliver, how the power is distributing from actuators or drive systems to the robots. Next one is waist as well as base. The base of the component, the base of the robot is called as a base. The main thing, I mean, if there is a ground is there, if the ground is there and a robot need to mount, robot need to fix to the fix on the ground, then there is some medium, that medium is called as a base. Okay, where what will be happen, this base will be mounted on the ground with some eye holes or eye hook joints. So that what will be happen, so whatever the end application may be, your end application may be 100 kg or 200 kg, so based upon the application which the robot is performing, this base will be defined. If the application is somewhat 200 kg or 300 kg, then what will be happen, the base will be this much of length here. Instead of a smaller circle, smaller cylinder here, there will be having a huge cylinder if the robot component is more, if the weighing capacity of the robot is more. So based upon the weighing capacity or based upon the payload of the robot, the base will be defined. Now the robot and base are going to connect with a joint that is called as a waist. Okay, just a second, let me erase all these things. Here see, now this is one, the one is going to rotate in 360 degrees, okay, like this. So how it will rotate, so if this arm one will directly fix to the base, will it be possible? See, there is a base here and there is an arm here. Now if these two are welded, is it possible to rotate 360 degrees, even 1 degree?
No, sir.
Why?
No, sir.
Because there is a fixer here. So if at all I want this motion, if at all I want to move in circular rotation 360 degrees, then there should be having some joint with which it will going to rotate. At the same time, the base and this robot need to connected. So that is how the waste will comes into existence. Now what will be happened? This robot, just a second. This is the first arm and there is a base. Now these two will be fixed by a joint like this. This is a fixed one. This is completely fixed. Or maybe it is having some moving involved in it. So because of which what will be happened? This will going to rotate. That is what exactly it is. Okay, that is the main purpose of waste base. Just a second. Now coming to end effector. End effector is nothing but, see, we have done base, motor, power cable, lower arm, link, joint, upper arm. Now this part. End effector is nothing but wrist, end component of a manipulator or a last component of a manipulator. Okay, this is called as a end effector, which means in simply we will call as a wrist. In other words, we will call as a wrist. If at all we will be considering our hand as an example, then what will be happened? Our two different arms will be, lower arm, upper arm will be our links, whereas the wrist is nothing but our end effector. Okay, with the wrist, with our hand, what we are going to do, we can do any type of, I mean, we can reach any location, and by using the wrist we can pick any component, we can sign over there, we can do any application by using our wrist. Wrist and end effector are both are same. Okay, this is called wrist, where it is mounted to the manipulator. So here what will be happen, this wrist is also having some degrees of freedom, which means it can rotate, it can rotate, it can rotate. Why? Because there is a joint here. The wrist rotations I will explain you in the next phases. Okay, so this wrist is nothing but the end component of a manipulator, that is called as a end effector. Now, okay, fine, this is up to the structure of the robot, and the next components I will explain you in the next slides. Till now, we have discussed about what is a robot, why there is a need of robot, what are the strategies that will be needed for an involvement of robot at the same time. So, structure of robot we have defined as of now. Now, this one, classification, how the robots will be classified. So there will be having n number of robots in the market or in the industry. How they will be classified, on what basis they will be classified is this one. First of all, I explain you the classification, then I'll explain you in detail how they will be classified or everything. Okay, the robot will be classified into 6 different types: Cartesian, cylindrical, polar, articulated, Scara, and Puma. These are the 6 available robots in the market, and there are some other robots that will be defined based upon the application. But these 6 are the major. Okay, out of 6, okay, out of 6, 1, 2, 3, 4. These are the 4 primary classification based upon the movement of the robot, how the robot is going to move. That based upon that, the robots will be classified into 4 different types. These are the 4 main classification. So based upon these 4, the robots will be classified. Based upon the movement of the robot, the robots will be classified into these 4. Okay, now this Kara as well as Puma will comes into 4th component. Okay, there is this 4th robot is there, 4th classification is there. That 4th classification is again subdivided into 2. Okay, in simply I will explain you 1, 2, 3, and 4. 4 are the classifications of this robot, and there will be sub classification, that is 4.1 and 4.2. Okay, that is how exactly the robots will be classified. Now this classification can happen based upon the movement of the robot, how the robot will be moved. So based upon that, these will be happen. Now I'll explain you all those things in detail. First one is Cartesian coordination, Cartesian configuration. This we call as a Cartesian coordination, or else there is one more name for this one. This is called as a prismatic, PRIS. No. PRISMATIC, prismatic robot, or there is one more name, That is called as a linear robot. This is first classification. First classification nothing but, so anything we can call. So either it is a Cartesian coordination or a prismatic robot or a linear robot. Anything is fine. Here what happened is, the robot is, here I will be considering an example. So this is my arm 1, this is my arm 2, and this is my arm 3. Okay, A1, A2 and A3. There are three different arms here. Now what will be happen? The name itself, Cartesian coordination. Robots with Cartesian configuration consists of links, that is nothing but manipulators or arms, connected by linear joints. Okay, connected by linear joints, which is nothing but, see, these are all called as a, if at all I am talking about robot skeleton, then this is how the structure will be. There will be three different arms. All the movement will be in, this is L1, this is L2, and this is L3. Now I'll explain you. See here. Now what happened here is, this is a base here. The base is mounted here. Now A1. A1 is a stationary one. Okay, A1 is not going to move here. If at all this A2 is going to move in this direction. Okay, then what will be happen? The robot, based upon the joint here, there is a linear joint here, this is called as a J1. Based upon the J1, what will be happen? The robot will move in this direction. Okay, the A2, the complete A2 will going to move from this direction to this direction based upon this one. So that joint will be like a ball and screw or a rack and pinion joint. I hope you know rack and pinion, right? Have you heard this word, rack and pinion joint? Rack and pinion.
Yes, sir.
So in that what will be happen? So there is a complete rack will be fixed in this one, which means a lead screw. There is a complete chamber. There is a complete a plate like this where the teeth will be fixed like this. This part, this complete strip will be mounted on this A1. Now there is a joint here. Now there is a lead screw here, or a sample. What will happen? Now there is a screw here. If at all this screw will be continuously moving, there is a power given by using a motor. If at all this screw will be moving in clockwise direction, what will be happen? This is fixed one, this we can't move, this is a fixed one. Now what will be happen? See, best example, I will give you some more example. There is a motor is there, small motor, and if at all you give the power to this motor, positive and negative, what will be happen? This shaft will going to move, right or wrong? Hello.
Yes, sir.
So
Yes, sir.
if there is a power supply is there, I have given some battery connection. Placed upon the battery, I have given positive and negative terminal to this one. So it will be rotating in clockwise direction. If I reverse it, then what will be happening? It will be rotating counterclockwise direction. Now there is one more class. I have holded this one. I have holded the shaft very rigidly, or by using some wires I have fixed this one, and I have given power to this one. Now what will be happen?
So motor will rotate.
Yes, motor will rotate. Simple application. If the motor is fixed and the shaft is a free one, then automatically what will be happen? The shaft will going to move. If at all I have fixed the shaft, then automatically what will happen? The rotor is going to, the motor is going to move. Clear? Same application here also. If the lead screw, see this is what exactly the strip. If the strip is fixed one, or else one example, same application here I am using a motor, okay, and by for the motor the end part will be my lead screw, my this assembly, and there will be having some teeth here. If at all I give power supply to this one, what will be happen? This is not fixed one, this is a free one, this is a free strip. Now the what will be happen? The motor is fixed and the shaft is fixed and this lead screw is fixed. If at all I given the power supply, so because of the clockwise direction, what will be happen? This strip will going to move in this direction, right or wrong?
Yes, sir.
Guys, clear? Why? Because this is the basic of the movement, so you need to be thorough with this one. If there is a doubt, ask me again, I will explain you. But this should be the important thing for in this robotics. Clear? Do you want me explain again? Okay, in 3D I'm explaining you. There is a motor and there is a shaft and there is a gear is there. I'll explain you by using this language. There is a gear. Now there is a metal strip is there with which, so I will be having some screws, some thread will be having. Okay, now I have given power to this one. This motor is a fixed one, this is a completely fixed to the frame. Now I have given power supply, so because of the positive power supply, what will be happen, this will go into rotate in clockwise direction. Okay, now if this gear will rotate in clockwise direction, now what will be happen to this one, what will be happen to the strip, will it move or it should be fixed?
It will move.
Why?
So gear is rotating, so
Okay, so the gear is having some motion, some circular motion. At the same time, what will be happen, the teeth of the gear as well as strip were interlinked with each other. They have, there was in a complete junction is there, they will be connected with each other. So what will be happen, when there is a power supply, automatically this will rotate in this one. The same will going to happen in your conventional missions. In lathe bed, what will be happen, there will be a flywheel here. If you rotate the flywheel, automatically the carriage that will be sitting on this will going to move in this direction as well as this direction. How this will be happening, which means there is a lead screw here, which means there is a thread that will be involved in the strip, and there will be a power strip that will be here. So because of this connection, so whenever there is a movement, so automatically this will going to move. So because of this one, it will move like this. Same with this one also. Clear? Same application. If this motor is not fixed, if the strip is fixed, now what will happen? If the strip is fixed and I have given complete power supply to this motor, now what will happen?
Motor will rotate.
Yes, it will go into move in this direction. Why? Because this will go into rotate. So if this is rotating, what will be if the strip is stationary? So based upon the clockwise, it will be moving this direction. If it is anti-clockwise, this will move in this direction. The same will be happening in this one. Okay, this is called as a rack and pinion joint. Rack, this is a rack, this is a pinion. So based upon these two, it will be happen. Same here. If at all I want to move this A2 in upward and downward direction, then I need to give power supply to this, joint one, so that what will be happen, the power supply, because of the A1 is fixed, so this A2 is going to move in upward and downward direction. That is one linear. Now second one, this one, L2. So now I want to move this L2 in this direction, which means it will going to move up to this, like this, up to this section it can move from this to this one. L21, L22. L21 is a initial position and L22 is a final position. If at all I move in this direction, then how again I need to do? So what is the possible thing I need to adapt here? Same assembly, same here also I need to use some rack and pinion assembly, same assembly, so that what will be happen, whenever I have given power, so here it is going in upward and downward direction, it will, here it will be in lateral direction. There is no any difference we are using. See, if there is a linear movement is there, then rack and pinion joint will always comes into existence. Okay, this movement rack and pinion, this movement rack and pinion. Now this movement also there is a upward and downward direction, so this is also linear. Now how many linear are there here? How many linear movements are there here?
Two, six.
No. See here, we are considering plus or minus as 1 only. Plus or minus x, plus or minus y, plus or minus z. Now how many?
Three.
3. Okay, just a second. Now see here, there will be having, if at all I'm talking about this diagram, then what will be happen? The robot will going to move in this direction. See, this is a linear, first linear, straight line, same, this axis. Now we will talking about this one. Now what will be happen to this one? It will move in this direction. This is L2. Now what is the third one? In this one. This is L3. Now how many joints are there? How many movements are there here?
So 3.
3. That is why L. Okay, if the movement of robot is in linear direction, all the arms, all the joints motion is in linear direction, all the movement of joints in the robot is a linear, then we will call it as a Cartesian or a linear, or we will call it as a prismatic. Anything is correct. Okay, simple definition. So first definition, first classification is a Cartesian configuration or a linear configuration or a prismatic configuration, in which what will be happen, the joint, the links of the robot should supposed to move in a linear direction only. If at all we are talking about x, y, z, and all the movement of x, y, and z will be in a linear only. L3, L2, L1. There is no any rotary. Everything is a linear here. Then we will call it as a Cartesian. Clear?
Yes, sir.
Everyone, I need your input. Why? Because so if you are having doubt here, then it will be continuing. Why? Because next is some other things like cylindrical, so where there will be having some other things involved. So if you need to be thorough with the first one itself.
Yes, sir. Clear, sir.
Okay, fine, I will be considering as clear. If you are having any doubt, you can ask me, no problem in that. I will explain you in the mean also. Fine. See, now we'll coming into descriptive part. It consists of three orthogonal slides. Three slides are parallel to x, y, and z axis of the Cartesian coordinate system. So again, if this is an application, if you're talking about the application, then this bar, this is called as I will consider this as a. Now what will be happen? How the A will be moved? A will supposed to move in x direction. See here, positive and negative, in this direction, in this direction, that is called as A. Now B, if at all this need to move from this to this, then we'll call it as in y direction. B will supposed to move in y direction. Okay, if there is a C, this is called as C. If at all I want to move C upward and downward direction, then that is also possible in the linear direction. Now here see how many linear, linear 1, linear 2, linear 3, all the movements are in linear direction, then we will call it as a Cartesian or a linear joint. Commonly used for, these are some of the applications commonly used for pick and place application, assembly operations, handling machine tools, arc welding. Okay, these applications I will explain you once I have explained you all the classifications. Once you are thorough with 6 classifications, then I will explain you what type of application will be preferable for which robot. I will explain you after that. Okay, advantages: ability to do straight line insertions in furnace, easy computation programming, most rigid structure. Disadvantages: requires large operating volume, exposed grinding surfaces, only reach front itself. See, based upon the movement, so every robot is having its own advantages as well as disadvantages. So this is the movement. If at all I want to rotate it, if at all I want to place at this corner, so it is possible. Why? Because there is a movement. So if at all I want to rotate this component, if at all I want to rotate the component from 30 degrees, now the component is like this in rectangular. Now I don't want like this, I want like this. So it is not possible to rotate its direction to place here. At this, at that applications, this Cartesian will go into fail. Okay, now this is the second classification. The second classification is cylindrical classification. Okay, in which what will be happened? First one is a First one is a linear, in which everything is linear, linear, linear. In cylindrical, it is like a linear, linear, and rotary. See, a robot with cylindrical configuration have one rotary joint and two linear joints connected with links. That is what exactly the cylindrical configuration is. Now, talking about this example, here there is a arm. This is 1, this is 2, and this is 3. Now, see, first one is he has given some angle like theta, which means the first arm will going to rotate in 360 degrees, okay, which will be rotating like this. So first one is a rotary. See, which is not possible here. See, is there any rotational here?
No, sir.
Is it possible to rotate L1 or L2, L3? Is it possible?
No, sir.
It is not possible. Why? Because everything is a linear joint here. Whereas here there is a waist. By using that waist, we are going to rotate the first link or first arm in a theta direction. That is first one, R. Next one is same. See L. In L, what is happened here? For two application, it is going upward and downward direction. So, and third one is in and out direction. This in and down direction will also be linear. That is called as a cylindrical configuration. Clear? Cylindrical configuration will be having one rotary and two linears. So first one is itself. So if at all I'm talking about the same block diagram, then this arm will supposed to rotate in 360 degrees. This arm will going to move in this direction and this arm will going to move in this direction. Okay, L1, L2, L3. Here what will be happen? L1 it should be in rotating, L2 is like a inward and downward, L3 is like a upward and downward. So there will be having one rotary and two linear. Clear? This is called as a cylindrical configuration. Okay, cylindrical robots.
Sir,
Yes.
sir, a nomenclature of for cylindrical configuration.
Sorry, can you repeat it again? There is a disturbance.
Sir, I am asking that is LLR the nomenclature for cylindrical configuration and same for the uh, Cartesian configuration? Triple L is this nomenclature?
Yes, it's a nomenclature. It is how exactly we will be representing. So either it should be RLL or LRL. It should be your wish, but it should be having two linear and one rotary. This is the nomenclature of cylindrical. Everything is L in Cartesian. This is the nomenclature of this one. Okay. Now we will be entering into this one, Cartesian cylindrical robots. In this robot, the robot body is a vertical columns wheels around the vertical axis. The arm consists of several orthogonal slides. Okay. See here, one important thing here. There is a chamber here. I hope you have seen. See, this is the robot. Okay, these are the axes. This one I will call it as a link 1, link 2, and link 3. Okay, link 1, link 2, and link 3. Like in the previous example I explained you, first is having a waist here. So that what will be happen? So it should supposed to rotate, right? Now see here. If this component, if L2 and L3 are at ground position, now what will be happen? Clear? It's like this, right? No, it's not visible. Now see, if this L2 and L3 are at ground position, which means Y is 0, then what will be happened? It will be like this, right? Hello?
Sir,
Z is
Yes,
0.
sir.
Someone?
Sir, Z is 0.
Yes, okay, Z is 0. Here, this Z is 0. Okay, if Z is 0, what will be happened? It will be at this direction. Okay, it will be at the ground. Okay, now this robot is having, I mean, the first axis is a theta. So because of theta, what will be happen? This robot can rotate any degrees, 360 degrees. Now if at all I am considering this as 0, okay, so that what will be happen? This robot can reach like this up to 360 degrees. I'll consider this as 360, so that it will complete a circle. So this is what exactly its working area, okay, in the ground if z is 0, okay, clear?
Yes, sir.
If the
Yes,
z,
sir.
if the z is having some 10 units, now what will be happen? If z is 0, then this first line, this is first. If z is 10, now what will be happen?
It will be lifted.
It will be lifted, and the same capacity, see here, this is not at all changing, and the same capacity up to this it will be reaching, okay, this is z is 10. Now if the maximum height of the shaft is 40, now at 40 what will be happened?
Seems.
Okay, now what happens? See, the maximum reach of the robot is the outer circle. This is the outer circle, this is the maximum reach. It is the maximum limit where the robot will going to reach. That is the this one. Now we'll considering about, so we have talked about this one, I mean first arm. Because of the rotation we will be getting this much of a value. Because of change in z also we will be getting this height. Now what is this y value? The maximum y is nothing but 20. If there is a y 20, then I'll be getting this outer circle. If the y is 0, then I will be getting this inner circle. Okay,
Yes, sir.
clear?
Yes, sir.
See, simple example, like we draw circles by using this compass protractor. Okay, so what happened, one point will be at this and one point at this, like this, so that we will be getting a circle. What is the maximum? If the maximum is at this position, okay, so we can draw like this. What is the minimum? So this is the minimum point, minimum is here. So this is the working area, so with which we can draw at 5 mm, 1 centimeter, 2 centimeter, 3 centimeters, up to 15 centimeters we can draw by using a circular, right? Clear? This is the on x-axis, on a plane. If the same, if at all I want to do the same at some height, what will be happen? The same will be getting. That is what exactly this one is, okay, which is nothing but envelope. We'll call, technically we'll call it as a robot envelope. Okay, robot envelope is nothing but the maximum area where the robot is going to cover. From the minimum to maximum area where the robot is going to cover is nothing but the robot envelope, or the working area of the robot is known as a working envelope, robot envelope. Clear?
Yes, sir.
Yes.
See, this is what exactly work envelope. So which means this is the inner radius. This y is, if the y is 0, then what will be happened? The gripper is at this location. If the gripper is at this location, then I will be getting this inner circle. If the gripper is maximum, then I will be getting outer circle. Okay, that is the first condition. Second condition is this one, y. If this zz, if the z is 0, then I will be getting this inner circle at ground level. If the z is at maximum, z max, then I am getting this higher circle. And because of this theta, I will be getting the circle radius. If the radius is having 360 degrees, then I will be getting complete circle. If the theta is 240 degrees only, then I will be getting a part of circle. If the robot is having only 45 degrees, then I will be getting only this part only. Then if at all I am talking about 45, then I will be getting only this part of circle. This is called as a robot envelope. Clear? Robot
Yes, sir.
envelope is nothing but the
Yes,
working
sir.
area, the maximum working area of the robot, or the maximum reach of the robot, or the working envelope of a robot. Okay, like this is also having its
So,
own.
or we can say volume.
Yes, volume is also correct. See now, third classification. Now the third classification. Here in linear, what happened? LLL. In cylindrical, LLR. In spherical, it should be like L, R, R. That is called as a spherical robot or polar robot. Generally, we'll call it as a spherical robots. Now see, a robot with one prismatic joint and two rotary joints. The axis consists of polar coordinate systems. See, this is what exactly the envelope. Now you will be having see, it is visible, I hope so. This working. Now what happened here? If at all I'm talking about the same skeleton of the robot. If this is my skeleton, first arm is rotating, theta 1. R1. Second arm, okay, this is L1, this is L2, and this is L3. Now here, this is second arm. This second arm will go into rotate in this direction, which means upward and downward, so that it will be reaching to maximum location. Okay, this is L21, this is L22, initial position, final position. So that what will be happening? It will be moving in this direction. This is theta 2. And third one is linear. See, it is not doing anything. There is a linear movement only. L3 is like in this direction, upward and downward direction. Here or here, it is doing the same thing. It is moving in this direction only. So theta 1 is a rotation for the base. Theta 2 is nothing but the L2 is going to move from like this. So if there is a joint, then it will going to move from this direction to this direction. Okay, this is theta 2. That is called as a R, and L. This is called as a spherical robot. So now we are talking, if at all we are talking about this envelope, okay, then the envelope will be like this. See, first joint is, this is my base. Okay, this is my base, and base is going to rotate. I have given the rotation command. So this is my rotation base. I mean the L1. L1 is going to rotate. This is L1. L1 is going to rotate, so I am getting theta 1. So because of the rotation, what will be happen? This circle is formed. Okay, that is theta 1. Previously what happened? There is a L here. So because of L, what will be happen? It will be moving in upward and downward direction. So that we will be getting a straight envelope. So we will be getting a straight envelope and the same circle. But here what happened? There is a movable one. So this is theta 1. It will go into move in this direction, theta 1, L1 theta 1. In the second application, it will go into move in this direction. Okay, from this to this. So that same will be happened. See here. This is the axis. Because of which what will be, this is theta 2 or L2. This is L2, for L2 theta 2. So it will going to move from 0 to the maximum reach, this one. Okay. Third one is a linear, same. Third one is linear. If the arm is linear, so it will going to move inward and downward direction. So based upon the inward and downward direction, what will be happen? This is the Y. And there is a circle in the base because of theta 1. There will be having circle in the side because of that theta 2. Okay, 2 linear. So 2 rotary. Rotary 1, rotary 2. That is R, R, L. Clear? LLL, LLR, LRR. This is the notation. This is the nomenclature of the spherical robots. Guys, clear? Same thing here. See, the robot movement is changing. Previously, if all the movement of the robot is in linear direction, which means the robot will going to move in the linear, and linear. Then we will call it as a linear. If one of the axis is rotating, then we will call it as a cylindrical. If two axes is rotating, then we will call it as a spherical. Okay. Then what should be the final one? What should be the articulated? This is the third. Now what should be this?
Trias.
Yes. LLL, LLR, LRR, and fourth one is RRR. This is nothing but articulated robot. See here, this is example. First is a rotation. Second is a rotation. Third, if at all I am talking about 3, then it is also a rotational joint. See, if at all I am talking about an actual robot, Then I will be discussing about this one. This is the base. The black color is base, which is mounted on the floor. This is fixed one. This yellow line, there is a yellow line here. This one. This is called as a waist. This joint is called as a waist. Now what will be happen? Because of the waist, this will going to rotate in 360 degrees. That is theta 1. Clear? Because of the base, what will be happen? This robot is going to rotate in 360 degrees. That is R1. Next one. See, this is a joint 2. There is a joint 2 here. This is J1. This is J2. So because of J2, what will be happened? 1, this is 1, this is 2, and this is 3. Now you tell me. So what will be happen because of J2? Will I get a rotary or will I get a linear direction? In this diagram.
Rotary, sir.
Then how it will move? What would be its...
Sir, the other links will move now. So link connected to that joint will move.
Yes. So this is the axis. If at all I'm talking about axis, then what will be happen? So by considering this axis will going to move in this direction, angle from back to forth. Okay. So which means this will go into this as well as this will go into this. This is called as a theta 2. Second R. Third R. This is joint number 3. Because of joint 3, what will be happened? Where exactly it will going to rotate? So this arm, the angle between these two will also going to change. This is theta 3. Theta 3 may
So
be,
up and down motion.
yes, up and down motion. Maybe sometimes theta 3 will be 5 degrees, maybe sometimes theta 3 will be 50 degrees. So based upon that, this will going to rotate in this direction. Okay, this is RRR. If every robot, if the movement of the robot is completely rotational in the robot, then we will call it as an articulated robot, which is the generalized or the most used robot in the industry. So with this robot, we can perform any type of task in industry, whether it may be a material handling, whether it may be a spot welding, whether it may be a spray painting, whether it may be a arc welding, any application that can be performed by this articulated robot. Why? Because it is having freeness, high degrees of freedom. See, if at all this robot need to reach at this corner, it is possible. Why? Because if at all it wanted, it can rotate theta 1. If it is needed, it can rotate theta 2. If it is needed, then it will rotate theta 3 and it will reach to this location. There is no any constraint for this articulated robot. That is why it is called as a mostly used industrial robot is a articulated robot. Well, all the movement in rotary
Sir,
direction. Yes.
sir, sir, there is a rotation in its wrist also.
Yes. First is a
Is
base.
the end.
See, I will explain you this also. This is the base. This is the first thing, principle. This wrist will be anyhow, it will going to rotate. It won't, I mean, the wrist or a end effector will definitely rotate. It can't slide. Why? Because one end is completely fixed to this manipulator to hold its position. So this is a fixed one. Now I am going to rotate it only. So the wrist I will explain you in the later session. First be thorough with this principle. Okay. So now this one, the robot skeleton is having all the rotations in a rotary direction. Then we will call it as a articulated robot, and it is a most widely used robot in the industry. Now see here, robot envelope or volume. We will call it as a envelope or volume. Robot envelope. Now see here, if it is articulated robot, then it is a having a huge area to cover. It can cover any particle in the space in the given sphere, which means it can reach 360 degrees in the circle. It can reach 360 degrees in this direction. At the same time, 360 degrees in the internal also. Everywhere it should supposed to cover.
Sir, throughout this four classification, we don't take movement of the. We only take the movement of the skeleton.
Yes, So we are
Not the
talking,
wrist.
as of now, we are talking about only three: arm 1, arm 2, and arm 3 only. We have considered all these things only. See here, all the skeleton will be depending upon arm 1 and arm 3 only. Here there is a gripper is there. This gripper movement, this is a linear movement, but we haven't considered the gripper movement here. Same with this also. Here there is no any gripper. Here there is no any gripper. Gripper is there, but its movement is a fixed one. It will be moving in this direction.
What if the end part wrist has a rotatory movement? In the
Yes.
first slide, LLL.
This one. Still the robot is having
Next,
LLL only.
next.
LLL. See, the robot movement, main robot movement, the prism. See here, we are talking about links. We are talking about links, not end effector. So we are considering the links as well as joints here. So we are not discussing about end effector or wrist. So all these things, all the robots will be classified based upon the links, based upon the manipulators only. Manipulator and its movement, but not on the movement of end effector. End effector is a special application. See, if your application is this one, finally, if at all you want to change, you can go here. If at all you want to change, you can go for a rotational wrist. So if at all you want to do, you can do that application. But the robot movement will be defined. The robot movement is constrained. The robot movement constrained by these classifications: Cartesian, cylindrical, all these things by this robot only, which means all the arms. Okay. Now see, this is the envelope, working envelope of the robot. Here, articulated robot have all the joints in single axis revolutionary and rotary type. The chain of the revolute joints provide greater freedom and flexibility of the articulated robots. Scara and Puma are the most popular used articulated robots in the assembly line as well as package sections in this process. Like I already told you in the first session, the robot main classification depends upon the main classified into four types: 1, 2, 3, 4. That is nothing but LLL, LLR, LRR, and RRR. Then what are these additional? Then there will be two more additional, that is called as a 4.1 and 4.2. 4.1 and 4.2 are nothing but SCARA, SCARA, and Puma. Both are application oriented. So based upon the end application, they will be defined. So which means this application. Here, this is called as a SCARA robot. Where what will be happened? One additional axis was attached, and that additional axis was a linear one, which means R, 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 and fourth axis is L. This is SCARA. If R, 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 then we will call it as a Puma. This is SCARA and this is Puma. See, especially for assembly applications, we will use this as a, that is why linear joint is coming. SCARA is nothing but a assembly application, mostly used for the assembly applications. So in which what will be happen? Three rotary joints. See this one. This one, it is having theta 1, which is, it is a rotational one, and theta 2 is also rotational, and this is a third one. This is also rotational, which means it is having three R's, R, 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 and there is one more link. This is a link one, and it should supposed to move in this direction. This is linear. That is why R, 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 L. Three rotary directions and one linear direction. Then we'll call it as a SCARA robot. This is used for a special applications like assembly operations. See, this is one of the example. Now what will be happen? See here. This is link 1, link 2, link 3, and link 4. Now what is the link 1 movement? Will it be a linear or rotary?
Rotary.
Rotary.
Based upon that one, what will be happen? This one will going to move in this theta direction. This is theta 1. Now what will be happen to this L2? How it will be going to move? Sorry, this L3.
So rotary.
Rotary. So this is theta 2.
So same theta. So
Same with this also. This also move in this one. But additionally, this will be moving in upward and downward direction. This is L1. Theta 1, theta 2, theta 3, and L1. That is why 3 rear rotary and 1 linear. That is Kara. Okay. This one, see. Puma. In that Puma, what will be happen? See, this is the first R. This is the second R. And this is the third R. And the fourth, this is also R. Based upon this, Puma has a greater flexibility than SCARA with the increased complex in the reduction process. Puma is most commonly used in industrial application, assembly, welding operation, and laboratories. Puma resembles more closely to a human arm than SCARA. Puma has a greater flexibility. Thus, Puma is preferably used in assembly applications which do not require high precision, such as welding and shocking applications. These are some of the applications of Puma. Okay. Now, see, these are the classifications. Okay. I hope you are thorough with this one. Okay, there are 6 classifications. Out of 6, 4 are the main classifications. Those are nothing but, first one is a Cartesian or a linear, second one is a cylindrical, third one is a, what is third one? Third one is spherical, and fourth one is a,
Spherical.
yes, fourth one is articulated. Okay, and again the fourth will be subclassified into two, that is called as a SCARA and Puma. SCARA is nothing but there will be having 3 rotary and 1 additional linear joint, whereas Puma is having all the rotational joints. These two are generally used for the assembly or special applications where there is a need of additional arm. Okay, now SCARA and Puma. Now we will be talking about this one, basic motion systems. Till now we have discussed about the robotic structure. Now we are going to discuss about wrist. So how the wrist is going to move, how it will be differentiated, how the movements will be controlled. See, that is involved in this 6 degrees of freedom. As of now we have talked about 3 degrees of freedom for a robot, right? We are considering only linear direction. So if the robot is moving in linear direction, then what is the thing? If the robot is LLL robot, linear robot, now what is the degrees of freedom here?
3.
Why? Because the linear movements will be constrained to 3. Now what will be happen to SCARA?
Sir, it will have 6.
How you say 6?
सर बिकॉज वो हमने इसमें पहले ही पढ़ा है कि ये पूरा ओवरऑल कवर करेगा तो हर डायरेक्शन में जाएगा तो 6 डिग्री ऑफ फ्रीडम हो जाएगा ना.
I will say 4. Why?
So it
Because
will have 4.
yes, I haven't touched this one. I haven't touched about the, if at all I'm talking about rotary, then I'm not considering linear here. I'm considering only one thing. See here in this robot also, in the linear robot, there will be having only linear we are collecting. So you are not collecting. I mean we are not involving this rotary direction here. That is why 3 here. Same with the SCARAs. If at all I'm talking about SCARA, then in basically I will be saving 4. As well as Puma I will be saving 4. Okay, but in general what will be happen, robot will be having 6 degrees of freedom. That 6 degrees of freedom is nothing but linear, 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 rotary, rotary, rotary. Okay, so if this robot is having only linear, it shouldn't be having any rotary, then how can we say that this robot is having only 3 degrees of freedom? Why can't we say 6 degrees of freedom?
So because it does not have other 3 degrees of freedom, that is rotary one.
Yes. So as of now, we are discussing about the up to manipulator only. So we haven't started this end effector. That is nothing but our wrist. So if the wrist is attached to the robot, then the robot will be having 6 degrees of freedom. Why? Because the robot itself, the robot anyhow it will be having, see, these 3. It will going to rotate along with Z, it will going to rotate along with Y, it will going to rotate along with X direction. These 3 will be involved and together we will be calling it as a 6 degrees of freedom. Okay, see here, 6 degrees of freedom is nothing but it provides the robot the capability to move and perform predetermined tasks. These 6 degrees of freedom are intended to follow versatility of movement pursued by the human arm. The basic 6-degree motion consists of 3 arms, body motion, and a wrist motion. These will be 6 degrees of freedom. Okay. Now, what will be happen to this SCARA? I have attached a wrist to this one. Now, how many it should be having?
6.
The maximum will be 6. Okay. See, here we are talking
Yes, sir,
about
but it will.
linear, 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 and there will be one rotary. If at all I am attaching a wrist to this one, so a wrist is also having linear, linear, linear. Then what will be? I mean, if the wrist is also having R, 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 then what will be happen?
So then it will have 6.
No, it will be having 4 only. Why? Because see, the robot linear one, I mean L1, link 1 is having some theta. Okay, so if at all I'm talking about, this is the robot, this is the base. Okay, this L1 is going to rotate in theta 1 direction. Okay, and there is an end effector and there is a gripper. That gripper will also rotate in the same direction. Then we can't count it as a 2 degrees of freedom. Why? Because both are in same direction, right? This is L1 and this is L4. This is theta 1 and theta 4. Theta 1 and theta 4 are both in same direction. If they are both in same direction, then how can we say that is 2? That is the one of the logic here. See, that is why we will be calling a 6 degrees of freedom. 6 degrees of freedom should be in LLL and RRR only. So if the robot is having all the RR, 6 R's, all the rotation, then we will be calling it as 6. Why? Because again, this will be differ and this will be differed at these applications. Okay, see, I will explain you in clear. The robot base will be differ, gripper will be differ. Okay, so in these applications we can't say that theta 1 and theta 4 are in same direction. That is why we will be counting it as a 1. We can't say that. So if the robot is having, I mean if the robot, like the SCARA, what will be happen, the first will be in rotation, and the same there will be one more axis that is also in rotation, which means theta 1 and theta 3 are same. Now it will be having 1 degree of freedom. Why? Because we are talking about links here. For links, there will be having 3 degrees of freedom. For manipulator, we will be having, sorry, for wrist, we will be having 3 degrees of freedom. Together, the robot is having 6 finally. Okay. The special applications like SCARA and Puma
Sir,
will be considered. Yes.
Sir, it will have 6 degree of freedom. It doesn't matter all the 6 are rotary
Yes,
or all
yes,
the 6
yes.
are
That
linear.
is what I'm saying. It doesn't matter. Either it should be circular, it should be linear, it should be having combination of linear as well as rotary. It doesn't matter. But wrist is having its own degrees of freedom. Robot is having its own degrees of freedom. The robot degrees of freedom will be considering with 3, as well as wrist will be considering with 3. So together we will be calling it as a 6. And each and every degrees of freedom is having its own terminology also. Like we talked about the wrist, then we will be having roll, pitch, and yaw. If at all we will talking considering about the robot, I mean the skeleton of the robot, then it will be like a longitudinal transverse, rotational traverse, and one more thing, there will be one other traverse. There will be, we'll call it as a transverse. We'll be calling it as a roll, pitch, yaw. Each and every degree of freedom is having its own name. That is what exactly I'm saying. So if the skeleton is having two similar one, then we will be considering it as a one. But if the robot is similar with the end effector, we are not going to consider these two as a similar one. So we will be considering this as separate and this will be as separate. Together the robot will be having 6 degrees of freedom in actual. In particular, if at all we want, we will be having 12 degrees of freedom. 12 degrees of freedom with respect to positive as well as negative separately. So 6 degrees of freedom where we are considering positive and negative in as a 1. Okay. See, if there is a positive x, then we will be considering it as a 1. Negative, we will be considering it as a 1. Together it will be having 2 in this notation. Whereas in regular notation, it will be having 1. There is a moment in x. That moment will be, that's up to its robot only. Whether it may be a positive, it may be negative, it doesn't matter. The row x-axis will be having only one moment in this condition. If in particular if at all we want, then it will be having 12 degrees of freedom in positive as well as negative environment. That is called as a degrees of freedom. Okay. There is a video in which everything will be explained in clear. I will be explaining you that in tomorrow session. I will be explaining this and I will be ending today's session. Okay. Like already told you, robot will be having separate degrees of freedom and wrist is having separate degrees of freedom. Here it is. Rotational, vertical, and radial. Rotation about the vertical axis, right and left spill of the right bottom. Vertical transverse, up and down motion of the arm caused by pivoting arm. Radial, extension and retraction of the arm, in and out movement. So if at all we are talking about this robot skeleton. So when we are considering this wrist, then we will be talking about these things. Wrist, which means roll, pitch, and yaw. In simply, we'll call it as a roll, pitch, and yaw. Roll is nothing but rotation of the wrist. So if we consider your hand itself, just consider your hand and will try to rotate it, then it is called as a wrist. So if you are moving upward and downward direction, then we will call it as a pitch. Then we are moving side direction, then we will call it as a yaw. This is called as a robot movement. So if you consider your hand as a robotic arm, then moving your arm, moving your arm, that is nothing but these things, these three things: rotational, vertical, and transverse. Moving your wrist is nothing but roll, pitch, yaw. Roll is nothing but rotation of the wrist. Pitch is nothing but upward and downward. Yaw is like a swivel of the, sideward direction of the wrist. These are the rotations. These are the movements of the robot we'll considering. So each and everything will be considering as a 1 1 1 and 1 1 1. Together we will be calling as a robot as having a 6 degrees of freedom. Finally, okay. In tomorrow's session, I will be showing you a video with which it is explaining each and everything in detail. So what is a rotational, what is horizontal, what is a radial, so how the degrees of freedom will be classified, so how we are going to say roll, how we are going to say pitch, how we are going to say, yeah, all these things we will be discussing in the tomorrow's session by using a simple video, by starting with a simple video. Okay, clear so far?
Yes, sir.
Okay, again
Yes,
I will
sir.
be
Yes, sir.
explaining you this degrees of freedom complete session tomorrow. So don't worry if you are having some doubts regarding the degrees of freedom. I will explain you tomorrow after the video. So once you go through the video, then you will be having a clear idea. Why? Because instead of explaining you in here, if you see a video, so what will be happening, you will be getting a clear idea on how exactly in 3D it will be representing. So in 3 dimension, how exactly it will be visible, so that you will be having a clear idea on the things which I am explaining you. So you will be correlated it further. Okay, tomorrow I will going to explain it. Any doubt so
Civil,
far?
sir.
Yes.
Sir, I think you skipped advantages and disadvantages part of all those.
Yeah, fine, no problem. I'll explain you. See, once you will be having clear idea on all these degrees of freedom, then there will be having a, see, anyhow I will be having all these things covered at that time. There will be having, where is this complete slide for that one. See, advantage of robot, in that there will be a video showing each and every robot, how the robot will be, so for every application how it will be classified. So disadvantages, limitations, all those things will be covered in the later sessions. Okay,
Okay, sir.
fine. That's it from, that's it guys for today's session. Any doubts? I hope so. Any doubts
No,
so
sir.
far?
Thank you, sir.
Clear? Then no
Thank
problem.
you, sir.
Okay, thank
Thank
you.
you, sir.
Thank you, sir.
Okay, thank you.
Thank you, sir.
Have a great day, sir.
Okay, thank you to you too. Bye.
Sir,
Yes.
can you go back to Puma slide? I want to ask one question. जैसे आपने कहा था कि इसमें 4R रहेंगे, तो सर अगर 3R हैं तो वो तो सफिशिएंट है ना सर, मतलब वो तो 3 डिग्री ऑफ रोटेटरी फ्रीडम है ही उनके पास,
See.
तो हमें 4th R की क्यों जरूरत पड़ेगी?
Yes, I will explain you this. See here, let me on this one. ये R है ना? Okay, so it is going to move in this direction as well as internal in this direction. But will it going to move in this direction? Is it possible?
No, sir.
Okay, so that is why I say based upon the application, if some application defines this one, then now what will be happen? Now I am going to hold some gripper that will be defining this application also, additional application. That is what exactly PMI is for. Special applications, special precise applications for that application. This additional movement is also needed. Then definitely there is a need. Now one more example. See here, there is a theta here. Okay, let us say theta 1. Okay, this theta 1 is having limitation. I hope you know. Why? Because up to some extent only it will rotate, up to maybe 30 degrees only it will going to move. Beyond that, if it try to reach, what will be happen? This arm is going to collide with this thing, right?
Yes, sir.
Now at that application, now the robot is in this direction. Now this arm is at this direction. Now I want to reduce this also. Now I will be reducing theta 2, so that I will try to come to some direction. This is theta 2, but it can't come to exact location. Why? Because again there will be having some limitation. Now still I want to go to exactly at 0 0 direction, axis, but at this application I can go for this one. I can go to that location by using this third arm. Why? Because this is smaller in length. Maybe because of this complexity, I will reach this location. Now I am having end effector. End effector, anyhow, it will be having 3 degrees of freedom: rotary, I mean raw, pitch, and yaw, pitch, and roll. Because of these 3 things, what can I do? I can pick a part, I can rotate it, I can do any type of application at that precise location. That is why we are using this additional accuracy. If at all the robot need to reach some special locations where the robot is not designed to move, at that application these type of robots can perform that type of movements.
Okay, sir. I understood.
Okay,
Thank you, sir.
thank you.